'Tis the season to be coding. And we're going to continue our coding journey with the turtle. The turtle is another object we can call up in Small Basic, much like with the text window and graphics window. And the turtle is a good way to get some experience controlling a movable object. Up until this point, we have been coding with text, we have been drawing graphics with code, drawing rectangles and ellipses and cool things like that, but we haven't dealt with anything that's moving. And we're going to be dealing with moving objects a lot when we do Game Maker and Minecraft, so why not control a little something in Small Basic as well? The turtle object allows us to do just that. So we can do 5 main things with this turtle. We can set its X coordinate, how far over to the right it is on the screen. We can set its Y coordinate, how far down we go on the screen. We can set the speed at which it moves. We can turn it a certain amount, and we can move it a certain distance. So we're going to be doing all of those things for the price of none, because it's free of charge. So let's take a look at this editor here, this code in here. So I have 2 editors opened up. We're going to take a look at the left one right now. So I wrote out right here, set the turtle's location and set its speed to 10. These are the codes I use to do that. So X and Y. Don't be intimidated by the fact that it looks like we're doing math here. All that we're doing is, much like with the shapes, actually, we're just determining how far we're going to move to the right and how far down we're moving. So if I set the turtle to if I set its X coordinate to 10, I'm only going out about this far. Remember, we're measuring from the upper left corner of the window. So maybe we're going out this far, and if I set Y to 500, I'm going this far down. So the Y coordinates kind of work the opposite way as it would on a typical graph that you do in math class, and that a positive number goes down instead of up. Because if it went up, well, that would be negative and it would be off the screen. So yeah, so 100 by 100, we can set the turtle speed to any number up through 10, so 1 through 10. 10 moves really fast, 1 moves, well, at a turtle's pace. We can also determine what kind of things the turtle draws. So yeah, the turtle draws lines as it moves, and we can change the color of those lines. We can also enter in codes like pen width. So graphics window dot pen width. Because the turtle is moving within a graphics window, so it's almost like 2 objects in one, actually. So we can use any of those graphics window codes that may apply to get the line's thickness to change. So right here, I draw a square with a random color. I use this code exactly as it is. Each time the turtle turns a certain amount, so these are the codes we would use to move and turn. The number in the turn code, in parentheses, determines how far to the right we move, or how far to the right we turn, excuse me. We can enter any number up through 360. I don't know why anyone would enter 360, because if we did that, we'd be turning and facing exactly where we started. It would be a full circle. So 180 would be halfway around, 90 would be a quarter of the way around, and 45 would be an eighth. And then you could just keep going on from there, smaller and smaller if you want to. Let's just see what this program looks like. Let me just enter in a smaller speed, just so we can see it more clearly. Turns right, turns right, turns right, and of course turns right. And it drew purple this time. Good, good. I could change the speed to 1 and it'll move really slowly. And yeah, we're not waiting for this. Okay, and if I enter in 10, it goes instantly. Notice how the color is different because it's a random color. So the X and Y coordinates were set to 100, then down 100, and this is where it started. It also happens to be where it ended. So yeah, that's how we can draw the circle. This number in the parentheses in the move code determines how far we move. So if I enter in 200 into just here, that's going to change the entire thing. Look at that. Of course, it still turned and moved in all of these same directions, and it moved in the same distances otherwise. So it still ended up making a square. It's just the first line ended up being longer. So yeah, we do have to be mindful of how far we move and the distance at which we travel, because that could affect the entire thing. It really didn't in this case, in that example, but it can. It's also good to know that if you enter in a negative number for turn, you'll turn to the left. And if you enter in a negative number for move, you will move backwards. So that's worth noting. And just changing it on those two numbers, just reduce the speed a little bit. Just changing on those two numbers changed how it moved. See, it turned to the left first and then moved backwards. But otherwise, it moved the same way. That green line really fit the color of the turtle, I have to say. Let's go over to the right editor right here. I can feel Old Man Winter knocking on the door. I don't know if he's going to treat us as kindly as he did in 2020, but we'll have to see. But in any case, I have a for loop right here that's going to create a snowflake shape. Now, let's just take a look at how it looks. Whoa, okay. Looks like the turtle is looks like he almost got electrocuted there for a second. But he ended up drawing something resembling a snowflake, so it looks pretty cool. I didn't bother to set it to a different color or anything, so it's just one solid shape. Okay, so I have the turtle speed set to 10. I have 4. T equals 1 to 10. So I declare a variable right here, t equals 1, and it's going to go up to 100. Okay, so I did that. It's going to move, I'll get back to this in a second, and it's going to turn 200 degrees each time, because that's what we're measuring in degrees. And that's it. So why did I write the name of the variable in here? Well, let's think about what number it's going to start off equaling. So the first time we go through this loop, the turtle is going to move a distance of 1, because that's the first number t is going to equal. It's then going to turn 200 degrees. Then we're going to go through the loop again, and the turtle is going to move a distance of 2, very, very short distance. Then it's going to turn another 200. Then it's going to move 3, then 4, then 5, all the way up to 100. So it's going to move a little bit more each time and turn the same amount. And the result of that, I'll turn the speed down, the result of that is going to be the turtle creating this snowflake shape. You can almost barely tell that it's moving forward at first, but the more times we go through this loop, the more you can clearly see that the turtle is moving forward every 200 degrees, every once in a while. Well, I mean, I set it to half the speed, so in theory it should only take twice the amount of time to draw the snowflake, but I feel like it's taking longer than that. Alright, let me just crank the speed up to 8. It's still taking too long. 9. I'm just impatient. Let's go. Let's put it back up to 10. There we go. That's nice and fast. Now we can see the snowflake shape being drawn. All right. That's pretty cool. And right before your very eyes, the code has changed. I added some things. What I did was I had it, or I'm going to have it, draw another snowflake. An identical snowflake in a different spot. What I need to do though is I need to move the turtle somewhere else after it's done drawing this one. So I need to use the code turtle.penUp so it doesn't draw a line while moving to the next spot. I'm going to have a move distance of 120 because I deemed that to be a good distance to move away. Then I need to put the pen back down as if we're writing on the paper again. So I need to use the code turtle.penDown. Then I have a nearly identical for loop as the first one, except with the letter changed. So I can't use the same variable I used here. So I'm going to use the letter V instead. T, V. Yep. And the result of that is going to be a second snowflake being drawn. So it's going to lift the pen up when it's going to the next spot. See how it didn't draw a line on its way over to the next snowflake, and then it drew another one. So I can take that a step further. I can just keep stacking different things we've learned on top of each other. So I'm going to paste what I have done here. So this is all that I had before, right? Doesn't seem like I added that much. I added a while loop. While L is less than 10, the L stands for loop, that's the variable I made. And then I add 1 to L each time we go through the loop. So yes, I have 2 for loops within a while loop. So we're going to draw 10 snowflakes here. In fact, what I need to do first is just say that L equals 1. There. So it's going to start off equaling 1. Let's just ignore everything in between because we already did all this. We don't need to even look at it again. Unless there's a problem, which there isn't. So while L is less than 10, L is going to equal 1. And now L is going to equal the last number it equaled plus 1 more. So next time L is going to equal 2. Oh, but you know what? Good thing I caught this. We need to say L equals 1 above the while loop. Because the reason for that is that means every time we go through the loop, L will reset back to 1, which we don't want. So when we're in the while loop, L is going to go up by 1. So if we do that, it should draw a snowflake, move on to the next one, and put the pen back down, then create another one, then do another one. So actually, it's going to draw 20 snowflakes. That's right. If I only wanted to draw 10, I would get rid of this. Let's run it and see how it looks. Looks the same so far, but it's going to move somewhere else. Of course, it's always going to turn, it's always going to move a distance of 120 from wherever it finishes, which could result, and it is resulting, with snowflakes being drawn on top of each other. So maybe I'll just have it move 150 or... yeah, 150. I was going to say 200, but you know what? It's probably going to go off the screen eventually anyway, so I guess it doesn't really matter. So yeah, this is how we... yeah, that's good. This is how we can stack different elements of code on top of each other. We can have for loops inside a while loop. We can have if statements within if statements, because we've done stuff like that already. Some of us have. Some of us did that for the ATM code, which is... it's possible to do it both with it and without it, depending on how you approach it. Ah, so this is, it's like drawing like a nice big pattern here. It's almost like a spike. It's almost like a wreath. Wow, that is actually pretty cool. This is literally, I swear, this is literally the first time I did it like this. I like that. I like it a lot. In fact, I'm going to save this picture. I really do like it. Wow. That's programming for you, folks. That is programming. Well, I hope you enjoyed this video and it gave you some insight onto the turtle. And I'll see you all soon.